Well, originally I was going to have three float switches, float sensors, or float switches inside the tank to monitor the level of the water inside the tank, and each one of those sensors would have a separate cable or wire conductors going back to the main controller board to determine if that was the level of the water was high, medium, or low. Well, I've scrapped that idea, but I actually did build the assembly to monitor that. See this? So these are three float switches. Inside these, when they go up, it opens. When it goes down, it closes. There's a ball with a switch and so forth. So anyway, they're on a PVC. Each one has a separate cable. I'll show you here. See this? Through the hole there and around, separate cable, each one of those. And each cable, 3 wires. So you can either wire it normally open or normally closed. Okay, that's kind of cool. So, but anyway, and this whole assembly would be hanging from the top, from the lid, right? See this? So it would be hanging from the top of the well of the storage tank and the lid. And that's one thing I did that one with all this in there and all these cables and all that stuff. Have to have the cables coming out the lid. But I bought these things. I put it all together. It's ready to go. I even have the wiring. It's already wired. There's 3 cables inside this box ready to come out. Actually, the wires, if that pole was inside the tank hanging from the lid here, well, there would be 3 wires coming out, and they'd be coming up this tube, and they connect inside there. But the wires are ready to go. The system is actually wired and ready to go for to have these 3 level float switches in there. But I had reservations. One thing I realized, there's all kinds of places for bacteria to colonize around that tube and inside the tube, around these little boxes and so forth. So, and also I didn't want to have this tube hanging down. Imagine me trying to take the lid off to look at the water inside and have this hanging from it. It'd be a real mess. So I've scrapped this idea. I'm not using that. What I'm going to use, I have not implemented it yet. I'm going to be using a submersible pressure sensor, submersible pressure transducer, they also would call that. So, and it'll be, 2 or 3 wires coming out of it, and I'll use the same conductors in that box that I just showed you, but I'm not going to be doing this. I paid the price for it. I put it all together, but I'm not going to use it. This is probably over $100 for this stuff right here. Oh well, I don't know what I'll ever use it for. Maybe I could try to sell it on eBay or something. I don't know. I could probably, that would be a good place to do it, or sell it on some kind of a platform there. So anyway, but just so you know though, the software that I'm going to show you is actually set up for this, for having the 3 level switches. So, in fact, the ports 0, 1, and 2 are these measure these 3 sensors: high, medium, and low. Just so you know what it's looking for. So right now, I just I occasionally go over to the well and open up the lid and look and see how high the water level is, because it doesn't fill up that fast, and I'm actually using it about as fast as it comes in. But some nights, though, it gets so high, I just have to come out here and turn the breaker off, because it can fill faster than I do use it, because I'm just, I only wash every other day maybe. So anyway, just so you got the big picture here what this is, okay? Because the software is going to talk about this. All right, so now we'll talk about the get into the software a little bit. So now this is going to go over a beginning of an overview for the software for on the Propeller microcontroller. That's a Parallax Propeller 1 microcontroller. And this program is written in C, or more precisely, is Propeller C. It's the C programming language configured to run on a Propeller 1 microcontroller. So the beginning of this one has this, like this is indicating these are comments, a big old block comment all the way down to that stops the comment. But all this here is comments. I'll read the first little paragraph here. This program manages real-time inputs from the input switches, including inputs from Hall effect sensors in the flow rate sensors, as well as outputs to the power relays that drive two pumps and AC power outlets within the well house. The two pumps are the submersible pump that is down in the well, and which transfers water to the water storage tank, and the booster pump that transfers water from the water storage tank to the bladder tank and subsequently to the house. Note that both the submersible pump and the booster pump are directly controlled by their respective pressure switches and are indirectly controlled by their respective power relays that connect 220 VAC to their respective pressure switches. So I'm not going to get too much into that for instance of time. I discussed previously with this part here, these libraries that are brought in. The previous video discusses this in more detail. Just note that these are all standard libraries except for this one, the CRC functions. I put that together, and my JSON utilities, that's together. So I'll discuss these two, probably these two here on the next video, probably. I can't make them too long. I can't put all in one video because I'm limited for each one. Plus, I'm trying to have them like bite size. I discussed all these input ports on the previous video, but note, remember that I showed you that those three level switches? Well, that's what this is all about. So that high switch out there, we go to port 0. This is, remember, port definitions. This is saying where on the propeller chip the data is coming in. So the high one would be on port 0, the middle one goes to port 1, and the low one goes on the port 2. But I discussed all these others on a previous video, so I'm not going to spend a lot of time on this video. The previous video discusses all the way down to about here. Okay, so I'm not going to discuss all this definition of all these ports. So further on down, okay, this defines the EEPROM base address and offsets from the base address. So the base address, you know, it's like a 32K. Well, it's actually 64K chip, but the bottom 32K is reserved for the software. The upper 32K, however, is, I can use that for a user, the EEPROM. So the base address for the upper area is 32768. That seems to be working just fine. And then now the factory, I have a factory default area, which is this here plus 100 times 4. And the 4 is, what happens is, that's 4 bytes, because those are longs. Those are, so for each of these has 4 bytes. And the EEPROM, each of them has 4 bytes. So integers, these are integers anyway. It's just storing integers. So 100, each integer is 4 bytes. So if I want the offset above these is 100 bytes, 100 integers above. So I have a procedure that'll take the factory defaults and copy them down to here. In case the user messes this up, we can always get back to factory defaults. That's what this is all about. And then this EE, all these are offsets within this area. These are offsets. Okay, so so for example, this 32768, this would be 4. Add 4 to this, I guess it would be right. So we have offset 1. And these here are time intervals in which the submersible pump will be enabled or disabled. So I have, because the propeller ship doesn't have any switches right now, any real-time clock. So this just tells that I divided that into 6 areas. So each interval is 4 hours. So this has to do with storage area for from 2 to 6, from 6 to 10, 10 to 1400, 1400 to 1800, 18 to 2200, 2200 to 2 a.m. That's what this is. These are the locations when EEPROM that are indicated. As if there's a 0 in that location, it means it's disabled. If there's a 1 in that location, it means it's enabled. And these are, this has to do with which switch is the top switch. I have it to where you can have, in either one of these, you can have 0, 1, or 2 in that location, that EEPROM location. Now, the reason I have use an EEPROM is whatever data is there will survive through a power fail. See, that's why we do that, because some things you don't want to have to. Once you've made the configuration change through the control panel, well, it writes it to the EEPROM. So that way, if you have a power failure, those changes you made aren't lost. That's why I use the EEPROM. So this is, anyway, it's just a bit confusing here. But anyway, let's I'll get into that later on. In fact, I'm not even going to be using this down the way, but it does work right now. It's all configured in. It does work. I ran it on my desk. I simulated all this on my desk and it's working just fine. So, okay, counter variables, I call that. But anyway, just so we get, I don't want to get too deep in what these are all these about. So these are just EEPROM storage locations and the description of what's stored in them. I have some integers. Now there's an integer array that these are indexed into the integer array and a description of what they are. These are offsets or indexed into the integer array that has certain values. And so the integer array would have 25 elements. If I even find it here, there we go. This is the integer. This is the integer array right here. And number of elements is 25. There's 25 different values in there. Define what true and false is. And these are some, now these here, now we get into this kind of stuff. These are function prototypes. And I'm going to talk about the function prototypes in the next video. Okay, so I just I'll include that in the next video, because otherwise the video will be too long. So okay, I'll get back with that on this. On video number 3, we'll begin and get into the function prototypes.